In late August, on a milkweed plant swaying in the meadows of southern Ontario, a female monarch butterfly deposits a single pale egg on the underside of a leaf. This egg, no larger than a pinhead, contains within it the beginning of one of nature's most remarkable journeys. The butterfly who will emerge from this egg will travel nearly 3,000 miles to a destination he has never seen, guided by instincts encoded over millions of years of evolution. 4 days after the egg is laid, a tiny caterpillar emerges. This is Milo, barely 2 millimeters long, pale and translucent. His first act of life is to consume the shell from which he emerged, a nutrient-rich meal that will fuel his initial growth. Within hours, he turns his attention to the milkweed leaf beneath him and begins to feed. The milkweed is both sustenance and defense. Its leaves contain cardinalides, toxic compounds that would prove fatal to most creatures. But the monarch caterpillar has evolved an immunity to these poisons. As Milo consumes the plant, he sequesters the toxins within his own body, making himself unpalatable to predators. His bold black, white, and yellow stripes serve as a warning to any bird or insect that might consider him a meal. For the next 2 weeks, Milo does nothing but eat. His growth is explosive. Every few days, his skin becomes too tight and he must molt, shedding his outer layer to accommodate his expanding body. He will undergo 5 of these molts, called instars, each time emerging larger and more distinctly patterned than before. By his final instar, he has increased his body mass by approximately 2,000 times. The tiny creature that emerged from the egg is now a plump caterpillar nearly 2 inches long. Throughout this period, Milo faces constant threats. Paper wasps patrol the milkweed patches, hunting for caterpillars to feed their larvae. Tachinid flies seek hosts in which to deposit their parasitic eggs. Spiders wait in ambush. Studies suggest that only about 10% of monarch eggs survive to become adult butterflies. Milo's survival thus far is a matter of fortune as much as instinct. In mid-September, a profound change overtakes Milo's body. The urge to eat diminishes, replaced by a compulsion to climb. He ascends the milkweed stalk and travels along a branch until he finds a suitable horizontal surface. Here, he spins a small pad of silk and attaches himself to it, hanging upside down in a J shape. His body begins to contract and pulse. What occurs next is one of the most extraordinary transformations in the natural world. Milo's caterpillar skin splits one final time, revealing not another, larger caterpillar, but a jade-green chrysalis adorned with a band of golden dots. Inside this protective casing, Milo's body essentially liquefies. His caterpillar tissues break down into a cellular soup, and from this primordial material, an entirely new creature begins to take shape. The chrysalis phase lasts approximately 10 to 14 days. During this time, wings form from specialized cells that have lain dormant since Milo was an embryo. Compound eyes develop. A proboscis takes shape, coiled like a watch spring. 6 jointed legs emerge. The caterpillar's leaf-grinding mandibles are replaced by structures designed for drinking nectar. On a cool morning in late September, the chrysalis turns transparent, revealing the orange and black wings folded within. The casing splits, and Milo emerges, his wings crumpled and wet. He hangs from the empty chrysalis, pumping fluid into his wings to expand them. For several hours, he remains motionless, allowing his wings to dry and harden. Only when they are fully functional does he take his first tentative flight. Milo is now an adult monarch butterfly, but he is unlike the monarchs that emerged earlier in the summer. Those butterflies lived only 2 to 6 weeks, their brief lives devoted to reproduction. Milo belongs to the supergeneration, the final brood of the year. His reproductive development is suspended, a biological state called diapause. He will not mate until the following spring. Instead, his body is primed for something far more demanding: migration. The urgency to move south is triggered by the shortening days and cooling temperatures. Milo does not know where he is going. He has never made this journey before. Yet encoded within his tiny brain, which weighs less than a gram, is a navigational system of remarkable sophistication. Using a time-compensated sun compass, Milo can determine his direction relative to the sun's position and adjust for its movement across the sky throughout the day. When clouds obscure the sun, he relies on the Earth's magnetic field, detected through specialized magnetoreceptors. In early October, Milo joins a stream of monarchs funneling south through the Great Lakes region. The butterflies do not travel in organized flocks, but move as individuals sharing a common direction. On favorable days, with tailwinds and clear skies, Milo covers 50 to 100 miles. He soars on thermals, columns of rising warm air, to conserve energy, gliding at altitudes that sometimes exceed several thousand feet. The journey is fraught with peril. Cold fronts bring temperatures that can immobilize butterflies, leaving them vulnerable on the ground. Storms batter them with rain and wind. Predators await at every stopover. Milo must also contend with an increasingly fragmented landscape. The prairies that once provided endless nectar sources have been converted to agriculture. Milkweed, his larval food plant, has been eradicated from millions of acres by herbicide-resistant crops. The refueling stations that sustained previous generations have disappeared. Milo pushes south through Missouri and into Kansas, following the Central Flyway. He stops to feed on goldenrod, asters, and late-blooming flowers, building fat reserves that will sustain him through the winter ahead. His body weight increases substantially, the stored lipids transforming him into a flying fuel tank. Without adequate reserves, he will not survive. As October progresses, the scattered streams of monarchs begin to converge. Milo crosses into Texas, where the migration corridor narrows. The butterflies funnel through gaps in the terrain, their numbers concentrating. Local observers report tens of thousands of monarchs passing through certain points each day. The sky at times appears painted with orange and black. The final leg of the journey takes Milo across the Rio Grande and into Mexico. He follows the Sierra Madre Oriental mountains southward, climbing to ever higher elevations. The air grows thin and cool. The landscape transforms from desert scrub to pine and oyamel fir forests. After traveling nearly 3,000 miles over approximately 2 months, Milo reaches his destination, the forested peaks of central Mexico's transvolcanic belt. Here, in a handful of mountain sanctuaries between 9,000 and 11,000 feet in elevation, the monarchs converge by the millions. Milo joins vast clusters of butterflies coating the trunks and branches of oyamel fir trees. The forest canopy provides protection from frost, while the cool temperatures keep the butterflies in a state of torpor, minimizing their energy expenditure. They hang in great orange curtains, so densely packed that tree branches sometimes break under their collective weight. Milo will remain here for approximately 4 months, from November through February, largely inactive. On warmer days, he and his companions descend to drink from nearby streams, replenishing the water lost through respiration. But mostly they wait, conserving the fat reserves that must last until spring. The overwintering colonies are vulnerable. Logging, both legal and illegal, has reduced the available habitat by more than half since the 1970s. Climate change brings increasingly unpredictable weather patterns. Severe storms can kill millions of butterflies in a single night. In March 2016, a winter storm struck the colonies and killed an estimated 6 to 7% of the entire overwintering population. As February gives way to March, the lengthening days trigger hormonal changes in the survivors. Milo's reproductive development, suspended since his emergence from the chrysalis, resumes. The urge to mate intensifies. The colonies begin to stir. Butterflies that have been largely dormant for months become active, feeding and basking in the strengthening sun. Milo courts a female through an elaborate ritual of flight and pheromone release. After mating, both butterflies begin the return journey northward. They travel into Texas and the Gulf states, where the female seeks out newly emerged milkweed plants on which to deposit her eggs. She will lay hundreds of eggs in her remaining weeks of life, her body finally depleted by the combined demands of migration and reproduction. Milo, too, has exhausted his reserves. His tattered wings, faded by months of sun exposure and frayed by countless flights, carry him as far as Oklahoma. There, on a warm April afternoon, 8 months after emerging from his chrysalis, Milo alights on a coneflower for the last time. His remarkable journey is complete. But Milo's legacy continues. His offspring are emerging across the southern United States, feeding on the milkweed their parents located. These butterflies will live only a few weeks, but they will push the population northward. Their children will continue the expansion. By summer, the great-grandchildren of Milo and his generation will have recolonized the northern reaches of the monarch's range, completing a multi-generational migration cycle that spans a continent. The monarch migration represents one of the most remarkable phenomena in the natural world. A creature weighing less than a gram, with a brain smaller than a pinhead, navigates thousands of miles to a destination it has never seen, using celestial and magnetic cues that scientists are only beginning to understand. The butterflies that return to Mexico each fall are the great-great-grandchildren of those that left the previous spring. Yet they find the same groves, sometimes the same trees. This ancient cycle, refined over millions of years, now faces unprecedented challenges. Habitat loss, climate change, pesticide use, and disease have reduced the monarch population by an estimated 80% since the 1990s. The overwintering colonies that once covered over 40 acres now occupy less than 7. Each year, the question grows more urgent. Will the migration survive? The answer depends on collective action across 3 nations. Habitat restoration efforts are underway. Milkweed planting initiatives engage millions of gardeners and landowners. Protected areas in Mexico receive increased enforcement. Scientists work to understand the monarch's needs so that conservation efforts can be targeted effectively. Milo's journey, repeated by millions of butterflies each year, speaks to the resilience of life and the intricate connections that bind ecosystems together. The monarchs do not recognize borders. Their survival depends on conditions across an entire continent. In protecting them, we protect not just a single species, but the broader web of life in which we all exist.